Alright, so hello guys. So in this video, what I want to do is I want to go over this problem. So this is going to be like a three-part video only because I don't want to do the sine, cosine, and tangent of theta over 2, or this expression, you know, the sine, cosine, and tangent of 112.5 degrees in one video, since I don't want to make it too long. So this is going to be part 1 of this video, and it's going to be a 3-part series. So here it says evaluate the trigonometric expression using the half angle formula. And what we have here is a sine of 112.5 degrees. Now, you want to remember that the sine of theta over 2, or the half angle formula for sine, is plus or minus the square root of 1 minus cosine of theta all over 2. Now, here it depends on what quadrant sine of theta is in, so what quadrant your angle is in. Now, if I look at sine of 105 degrees, I'm sorry, sine of 112.5 degrees, excuse me. Give me a second, guys. Okay, sorry about that, guys. Here we're gonna go ahead and you want to remember that the sine of 112 degrees, 0.5 degrees, excuse me. So, if I'm doing this, this is going to be the following, and we need to know that this has to equal the sine of theta over 2. So I know that, in other words, 112.5 degrees has to equal this. So set theta over 2 equal to 112.5 degrees and solve for theta. So this is my way of doing it, guys. So this is going to be the following. Theta over 2 is equal to 112.5 degrees. To solve for theta, we multiply by 2 on both sides, giving us theta is equal to, and let me just make sure that I remember what it is. It's going to be 225 degrees. So I know that, in other words, thus, sine of 112.5 degrees is equal to the sine of 225 degrees over 2. Now, if you do not know what sine of 225 degrees is, you can always just in terms of like degrees, if you like working with radians, you can always just convert the degrees to radians. What I mean is you can convert the 225 degrees to radians. So really, if I do that times, if I do that here, hold on, guys. Hold on. So we know that 225 pi over 180 is equal to 225 pi, which is actually, I'm sorry, is equal to 5 pi over 4, right? Now, you want to remember, and this is only if you don't remember, like, your, because for me personally, I like doing, radians, but if you remember what your sine, cosine, and tangent values are, in terms of degrees, you can just keep it as the sine of 225 degrees. I only do this because I personally like working with radians better, but it's up to you. So you don't have to do this. But we can say that the in our quadrant or in our coordinate plane, we can say that we know that, you know, here is 0, here's 90, here's 180, here's 270 degrees. I know that 225 has to be somewhere over here. In other words, this is 5 pi over 4. Now, I know that in quadrant 3, sine of theta is less than 0. So, in quadrant 3. Therefore, I know that sine of, and let me, hold on guys, 1 second. Okay, so I know that sine of 225, so in other words, thus, sine of 112.5 degrees, right? Again, is equal to the sine of 225 degrees over 2. And we know that 225 degrees is 5 pi over 4. So we have this is equal to the sine, which equals sine of 5 pi over 4 over 2. And we know that theta is 5 pi over 4. So, we know the following is going to be true. That, remember, we're using, so because sine of theta is less than 0 in quadrant, because sine of u is less than 0 in quadrant 3, then sine of u over 2 has to be less than 0. So, therefore, where u is equal to 225 degrees, thus sine, and let me write this down, hold on guys. Alright guys, so as you can see, this is what we end up getting. So now all we really have to do is we have to just evaluate this expression. This is negative the square root of the following, and let me actually just do a bigger square root here. Negative the square root of the quantity 1 minus, and remember that the cosine of 5 pi over 4 in quadrant 3 is going to be negative the square root of 2 over 2. So you must know your what is it called, your unit circle pretty well, your like your coordinates, the sine and cosine of each angle. Now we're gonna go ahead and substitute this in for this. So we know that this will, you know, this part is this, so it's gonna go minus the quantity negative the square root of 2 over 2. And I would not recommend, guys, evaluating this with a calculator because it's going to give you a decimal unless you have a calculator where it can actually do square roots or give it to you in terms of square roots. But then again, I don't know if your professor or teacher will allow that. God. So, yeah, do it by hand. Now, this is going to be 1 plus the square root of 2 over 2 because the negative cancels out, and then all over 2. which is equal to, and let me just kind of, hold on guys. Alright guys, so as you can see, we get the following, and this is how we evaluate the sine of theta over 2 being that it's negative in quadrant 3. And if y'all are confused, just look at what I did. It's just simple arithmetic, so that's why we can't really use, you know, I mean, of course you can always use like to simplify the top maybe, or not even, but we can clearly see that the final answer is this, and you wanna make sure that you put a negative there, because otherwise, you know, you want to remember that it's negative in quadrant 3, and so that is how we evaluate the sine of 112.5 degrees. And so that's going to be it for this video, guys. I'm going to do the cosine of this in another video. But if anybody does have any questions, please let me know, and thank y'all so much for watching. And please like, comment, and or subscribe, and I will see you guys in the next video. Bye guys.